Can I start? I won't start till you are silent, and if you don't become silent, I'll give you some topics to study on your own. So it's up to you. I still see you in specs. Are you even listening? Get out. Get out. Okay. So we talked about upcasting and downcasting yesterday. And I would like to address this question again. So it was like, why are we doing this? So I want to emphasize that again. Why are we doing all this? So why is this reference to superclass really important? Yoga Club OC members. I'll send you out to do some meditation if you'll go on like this. Okay. So why are we using this reference of superclass here? So although we have discussed that before, I'll again provide you a brief overview slowly. So the idea is, let's say you have this base class animal. I'm just using a rough example here, and you have created a lot of subclasses. Let's say cat, dog, lion, mouse, whatsoever. Right now, for some reasons, so there are two reasons to use it. There are two use cases why to use a reference to your superclass. The first is if you want a polymorphic array like this, as we discussed yesterday. So if you want an array of cats, you can make an array of cats, of dogs. But if you want an array of animals that can have some cats, some dogs, some lions, how do you do that? All of them are of different types. So in that case, you create an array of type animal references, and then you can go on. And this animal reference, it can point to a cat, dog, lion, mouse, whatsoever. So that is the first use case. Second use case is, let's say you want to have a function. So let's say each of these classes have a function called make sound. Right? How this particular animal makes sound, which works differently for cat, dog, lion, so on and so forth. Now you want to make a separate function. Let's say make animal talk. Let's say make talk. And what you want is, if you provide this function a cat object as an argument, it should create the sound of a cat. If you provide dog as an argument, it should create the sound of a dog, so on and so forth. So how many functions do you write? Multiple, right? So using the concept of method overloading, you can write multiple make talk functions, one of which takes a cat, one of which takes a dog. How many animals are there in the world? How many categories of animals are there? Are you going to make that many functions? At least 1,000 would be there. I guess it will be much, much more. But are you going to write 1,000 overloaded functions? Right? That doesn't make sense. So again, what you can do is you can use a reference of type animal here and call your function. Let's say animal A, and you can call your function A dot make sound. And that's all. You can pass it a cat, dog, lion, mouse, anything. So you won't have to write 100 functions for this. One function will suffice. So this is the most strong use of polymorphism that you can make. Now you take a moment to discuss with each other and tell me, have you encountered any such situation in your project? Have you seen any situation where you have a function? This function should be able to take any kind of object and work accordingly. So let's say you are creating an ERP system. You might have a class student, teacher, class, whatsoever. Can you think of a function that should be able to take object of type teacher or classroom or student and should be able to work accordingly? Can you think of any use case for this? No one is using any such sort of thing. Okay, so let's see. I'm saying, let's say your ERP system, there is an administrator, and administrator wants to know, let's say sometimes how many students are there in the system, how many teachers are there, how many classrooms are there, how are you going to implement that? So let's say you have a class administrator here. So this is a class, and in this class we want to have a function count, which mainly returns an integer, and the point is we should be able to pass anything to this count. A teacher, a student, a classroom, and it should be able to work according to that. Maybe tell you the count of each. So that is one probable use case of this. So two use cases, polymorphic arrays and polymorphic functions. Okay. Now let's extend this idea a little bit further. So I'm taking this as an example. So Disneyland fireworks is probably the most beautiful stuff I have seen so far in my life. So I thought I'll take this as an example. So let's say you are simulating this kind of a system. And can you identify some objects here? Fort, lights, fireworks, okay. Crackers, fireworks, what else? Light done. Light. Night. Okay, night. Would want that as an object, maybe. Okay, let's add that. Castle, okay. Anything else? Sounds. And so on and so forth. So you can think about a lot of objects here. Now let's say in order to simulate this system, you need to have some kind of sequence and obviously at the top audience. Right. So you want to simulate this system which goes on in a sequence of events. So the first thing is probably audience come and settle down. Then maybe the lights go off. Then maybe the fort lightens up. Then maybe there are certain sounds. Then maybe the fireworks start, so on and so forth. And in order to maintain this sequence, you might want to use a which data structure? A queue probably, right? Or an array. So let's say you want an array here where you want the first object to be audience. Let's say the second object should be lights. So something should be done with audience, and something should be done with lights, then something should be done with sounds, then something to do with fort, so on and so forth. How do you implement this array? So it's the same question. The same thing that we have been discussing so far. You still need a polymorphic array which can hold different kind of objects. The only thing that you see right now is these objects are not related to each other. Right? Previously, the objects we had, they were either all of them were animals or either all of them were employees of different categories. What do in this case? I want you to think and come up with a solution. What? Any idea? Some array, different array. Okay. But we don't want that, right? We can do. So if you have a class audience, you can make an array of audience. You have class code, you can make an array of phone. You can make an array of lights, you can make an array of sounds. But we want a single array which could hold each of these objects in a single polymorphic array. A method and call it every time. Use the method when you call, you don't also Later. So right now the question is about array. How do you make this array? What do you need? What is missing? We said that we can make a polymorphic array if you have a superclass reference, right? What will you do in this case? Separate class which like initialize this array. This class is something like them or like inherited from this array. Right. So one thing is as Snigdha said, create a superclass as we were doing so far. You create a superclass and you inherit all these classes from that superclass and use its reference. What will you name such a superclass? You see, if I say cat, dogs, lions, then it makes sense. I'll call my superclass animal. In this particular case, what do you call your superclass? Your subclasses are audience, fort, lights, castle, sound, and your is a relationship should satisfy. So if you say fort is a your superclass name, it should sound relevant. And if you say audience is a and whatever is your superclass name, it should sound relevant. Okay, Disney maybe a Disney object. You can say that. Let's say a Disney object. So you can create a class called as Disney object. That's one solution. And then you can go on, inherit all these subclasses, audience, lights, fireworks, etc. from this and make it work. Right? Okay. Now what I'll do is I'll add a few more objects there. I'll say, okay, there are certain things which are lying around. Let's say a spectacle, a books, a clouds. So this thing, its use case you will encounter in collections framework, which we will see later on. But the idea is now to have an array which can literally hold any kind of object. We are not just talking about Disneyland now. Like anything. So what you will do? Think about every single class in your project. We want an array which can hold any object. Now what do you do? Same thing, you again need to have a super class. Right? You need to have a super class and every single class in your project goes on and inherits this class. Right? That's one solution. You can call it something like a universal class. And whenever you make any class in your project, it extends universal class. You can go on and use the reference of a universal class. Now, this feature is so much required in object-oriented programming that Java by default implements it. So in this case, you don't have to create any particular superclass. There is actually a special class and its name is object. So it sounds ambiguous, but it's like object is a class in object-oriented programming. So it's the name of a class. You have a universal class called object, and whatever class, wherever you make it, it automatically extends object. So this is how it looks like. So let's say you are creating a class called employee. Somewhere else you are creating a completely unrelated class clock. Somewhere else you have name list, another class. But the point is automatically all of them are going to inherit the object class. And you can go ahead and use the references of object class to make these polymorphic arrays um, or to make a polymorphic function. So let's see a little bit about it, about the object class. So if you want to see more about the object class, what you can do is perhaps go to the Java documentation and all these classes that we have been using by default. You see like system, we don't need to import anything. We use system.out.println. String is a class, but we don't need to import it. So all of them are available in your java.lang package language. So that is by default imported. So I'm going to take a look at this object class. So you see here it's java.lang.object. So you can go here and read everything about it. Class object, it has one constructor object which will construct a new object already there. And here are some functions it has. So let's try some of these functions. So you have clone, equals, finalize, get class, hash code, notify, a lot of functions. Let's see some of these in action. So let's Let's take the toString function first. I think it's the simplest. So what it does, it returns you a string representation of the object. So let me go here and create a new file. Let me call it a hat. So I'm creating a class called hat, and let's take one data member color here, a constructor, which takes a string as an argument and sets the color of this hat to be color. And let's say you have a function called show hat, which says my hat is color. It just shows you the color of that hat. That's all. Right? There's a simple class hat as we have been writing till now. Let's create a class main with your main function. Okay. What I'm going to do is create an object of hat. And let's invoke h.showHat. That's all. Perfect. Anything wrong with this code? Everything all right? Take a look at this code. If you can't tell if everything is all right or not, we need to start object-oriented programming from the beginning. Constructor call is incorrect, right? So when you say new hat, you are calling a default constructor. But there is no default constructor here, which could work without an argument. So you need to provide the color here, right? Perfect. So now let's go ahead. Just checking whether it's working fine or not. Right, so this works. Now take a look at this. What we'll do is we'll say system dot out dot print ln h dot get string. Let me just check the name of the function. ToString. Look at string, ToString. Now, if you look at this function ToString, the point is that it's not at all there in the hat class. So do you see an error now? So we are calling h.ToString, but right now there is no ToString function in the hat class. So will it work? It's an inbuilt function, not in the hat class, but in the object class. So will it work? Yes. Why? Because hat is inheriting object. Right? And when you inherit a class, whatever data members and member functions of that class are, you can use that. So hat class can also go on and use this ToString function automatically. So let's check. So when you run this code, works fine, shows you some kind of hash code, some kind of memory object for this code. But let's say we don't want that. I don't like this ToString function working like this. Give me some kind of gibberish text. I want to make it more meaningful. Maybe show me something like uh, something like this, something what your show hat function is doing. So what can we do? So the point is your object class, that is, you are extending that class, right? So you can also override the functions of that class. So you can override this function. You can provide your own definition of ToString function, but in order to override this function, be careful about the signature of this function here. So if you look at toString, it returns a string. It's a public function. That's all, toString. You can just scroll down to see its definition. String. Yeah, so it's here. So you can read more about it here. Returns a string representation of the object, whatever this function does, which textually represents this object. So this is what this function is doing, but we don't want it to do this. We want it to do something else. So I'm going to override this function here. It's returning a string, and the function is toString. And what you can return is, instead of what we were originally returning, maybe return something like hat of color plus color. That's all. Right, so we have overridden this toString function of your object class. So let's see if it's working. Right now it doesn't show you that hexadecimal representation of the object. It says hat of color red. So have you ever wondered that when we were working with your string class, so there's one more thing here. So this toString function, you also needn't call it explicitly. If you only write h here, right? We have done that previously sometime. If you only write h here, even then also it implicitly calls your toString object. So toString function, I'm sorry. So even if you write h here, it still works the same way, hat of color red. One more thing here. So if you remember when we were working with strings are also classes in Java. And when you would print the value of a string, in that case also you don't see any hex code. You see the value of the string. That's also because your string class that is overriding this toString function so that you can see the string correctly. So just in case you were wondering. So let's look at one more function. So this equals function is also interesting. Uh, so you have this function called equals, which returns a Boolean value. So to this function, you can pass another object and it tells you whether both of those objects are equal or not. So let's do one thing. Let's create one more hat here. Hat k equals to new hat. And let's make it yellow. And let me say system.out.println. Again, you see the equals function is not defined here. I'm taking it from the object class and I'll say h dot equals k. What do you think will be the output? True or false? False. Okay, and what if I make it red? Let's check. So let's keep it red and blue and see what happens. Right, it says false. Okay. Let me make second hat, which is also red, but it's a different hat. Still false. Right? So what it is comparing here, you can again go, right? The object, their memory addresses. These are two different objects which have two different memory locations. So obviously they are not equal. So you can go and check in equals class what it is, equals method, what it is doing. It indicates whether some object is equal to this one or not. Okay. Now, let's say we want to override this equals method. This is a little bit tricky. Override this equals method here so that instead of checking whether they are the same objects in the memory or not, it's based on the color of the hat. So if both of the hats have red color, it should say yes, they are equal true. Otherwise, it should say they are not equal false. So let's try. So the definition of the function returns a Boolean type. Name of the function is equals. What is the type of argument it takes? object obj. So it's taking a reference of your class object. So let's do that. So let's say object obj. And what can I do now? What should we check for? The color. So if the color, you can also write this dot color so that there is no confusion. If the color of the object which is invoking this function is the same as obj dot color, you return true, else return false. Right? So let's check. I get an error. It says I cannot find the symbol color. Again, let's take a break and think about why are we seeing this error. Go up. So class hat, it has a string color, a constructor. And let me remove this for the time being so that you can see everything at one place. Equals is the function we are trying to override here. And that's how we are invoking it. H dot equals k. And it says that obj doesn't have a color. For class obj, it is unable to find the symbol color. This is something we talked about yesterday, if you remember, when we were talking about go to temple function of Hindu. And if a Hindu class has a function temple, and you try to access that, let's say a function or a data member temple, and then you try to access that through a reference of India, it's not going to work. Because for an Indian temple doesn't make sense. For a Hindu, it makes sense. So it's the same thing over here. We need to change the superclass reference. Right now, your superclass is object. And if you look at the object class, it doesn't have any attribute called color. Right? Color is an attribute of the current class that we made, which is a hat. Right? So we need to correct for that. So again, I'll just, so when you are doing this, when you call h dot equals k, if you remember how functions are called, this k goes and sits into object obj, right? K is an object of type hat. And now this object reference is going to point to this object of hat. So in this particular line, you can say that it is upcasting going on here. You are passing an object of hat, but you are collecting it in an object reference. That is what is upcasting, right? So you can say your hat is no longer a hat. Your hat K is no longer a hat. It has become an object. And an object in itself doesn't have any color. Hats have color. So what you need to do here, to change this reference, you cannot directly compare it to obj.color. Obj is not going to work here. You cannot use a reference of the superclass here. You need to use a reference of the subclass. So let's change that. How do you do that? So create a new reference of your hat H. Let's call it T for temporary equals to obj. So the same thing that is in obj goes and sits in T, but you need to downcast it to hat. You do that and then you check for if this dot color equals to T dot color. Now this is going to work because we are no longer using a reference to object class. We are using a reference of hat class, which is essentially pointing to the same object. So let's just check it. Right, so now it says true based on their colors. Now you have to be a little bit careful when you do this. So as an example, let's say I create one more class here. Let's say cap. I'm not providing anything in here. It's just an empty class. And what I'll do here is I'll create a cap C equals to new cap. And I'll say, okay, can you tell me what is h dot equals c? False, true. So what happens when you call h dot equals c? H has this equals method. Method signature is also correct because you are passing in a cap here, but your reference is object. Object type. Object can refer to any object. So you can pass in a cap over here. Do you think something wrong will happen in this line? So your hat is calling this method, your hat h is calling this method, and the argument that you are providing is actually a cap. So it's like there is a cap object, and currently your obj is pointing to this cap object and not to any hat object. And then in the next line, you try to do hat t equals to hat obj. Isn't there a problem? The object that you passed was actually a cap, and you are downcasting it to a hat. So let's try. Let's see it here. Right now it says caps equals to new cap cannot find symbol. Did I compile it? I compiled it. Okay, I'll be capital C. Capital C. Okay. The code compiles perfectly. You see, at the compilation time, there is absolutely no issue. So the compiler is unable to figure out what wrong is going to happen. But when you run this code, you get an exception, and it says you cannot cast your class cap to class hat. So there is a way only when this function is going to work that the object that you are providing here should be a hat because you are downcasting it to a hat. So one thing is you ensure that. If you do not ensure that, that will result into a runtime error. If you don't want that, then you can use the instance of operator to check it. So I want to see whether this obj that you are using, is it actually a hat or a cap? So you can check this. If your obj is an instance of hat, only then you do this. Only then you do this entire thing. Because only in that case this downcasting makes sense. If you are passing any other kind of obj, then you can simply return false because these are of two different classes. How can they be equal? If you want, you can define a functionality where you have a way to check between the objects of different classes also whether they are equal or not. It's totally up to you how you want to define this function equals. Right? So now it says false. Going into the second loop over here. Okay, so we'll look at a detailed example of this further in the lab today. Or let's do that. So let's do this. Let me give you a code. Okay, can you look at this code and tell me all your observations? So it's the code related to the same Disneyland example that we started with. Sound like a big code, it's just that it has a lot of classes, that's all. Okay, so the question is, can you create an array which can hold, let's say, two fireworks, two music, two lights, two crowds, and one timing? Can you add a line here to do that? So let's say we want an array here that can hold two firework objects, two music objects, two light objects. Let's say one crowd and one timing. Can you do that? Go ahead and do that. Our lab starts right now. The first question of today's lab. I'll add more and give it to you. We should not do any writing in today's lab. Submit your notebook as soon as you come to the lab. Next two labs, you don't have to write down anything. So for today's lab and next week's lab, so we just take your notebooks today, and I'll do the grading by my own. So you can do these programs in a group of 3 to 4 students. Before leaving the lab, you should show me the programs and explain them. This also. Yes.